All right, we're going to continue with a couple more examples talking about one statement being stronger than the other. So here it says, definition, statement P is stronger than statement Q if Q is true whenever P is true, but not conversely. So pretty much means if P implies Q is true, if P is true, but Q implied P isn't necessarily true if Q is true, then in this case, P would be the stronger statement. Okay, so we're going to use this idea to do these next two problems, or definition, I guess I should say. So I'm going to label these P and Q, and I consider each of the truth of each one and how that affects the other one. So I'm going to say if P is true, then Manchester United is the best football team in England. Manchester United is the best in England. Does that mean it's the best in Europe? Does that mean it is the best in Europe? What do you think? Well, no. Not necessarily. Say France or Germany might have a better team. So if P is true, that means Manchester United is the best in England. Does that mean it's the best in Europe? Absolutely not. Not necessarily. I mean, it could be, but we don't know for sure. There could exist a team in Germany or France or Spain that also has a team that's better than Manchester United. So we can say definitely that P doesn't automatically imply Q, because there could be a team in Europe that's better than Manchester United. We don't know. But if Q is true, Manchester United is the best in Europe now. So England is in Europe. So that implies that if Manchester United is the best in Europe, it has to be also the best in England because England is in Europe. So Manchester United being the best in Europe means it is the best in England as well. Why? Because England is in Europe. So we could say then that Q does imply P, definitely. So I have P does not imply Q, but Q implies P. So which one of these is a stronger statement? You would say Q is the stronger statement. All right? So let's try one more. Hopefully this will help solidify the idea. So which statement is stronger? N is divisible by 3, N is divisible by 12. So I'm going to label this P and Q. So if P is true, some number N is divisible by 3. Say the number 27. But that number is not also divisible by 12. Widget, hey, hold on just a sec. Widget. Sorry, I don't want to stop the video. My dog's going to start barking. So if P is true, N is divisible by 3, say a number 27. But 27 is not also divisible by 12. So here's one example. I have a number that is not divisible by 12 if it's divisible by 3. So counterexample, I can automatically say, well, if P is true, Q is not automatically true. So P does not imply Q. If Q is true, then N is divisible by 12. So let's just pick a number randomly. Here's some random number A, and I know that one of its factors is unknown, but this factor is 12. So A is divisible by 12. But if I continue the factor tree, I can say 12 is divisible by 4 and 3. So by default, if A is divisible by 12, it's also automatically divisible by 3. So if Q is true, N is divisible by 12, P is also true, N is divisible by 3. I don't know why I'm writing Y's there. If P is also true, N is divisible by 3. So Q is true, P is true, Q implies P. So which one's a stronger statement? Since this is not true always, but this is always true, that implies Q is a stronger statement. So Q is the stronger statement here. And if N is divisible by 12, then N is divisible by 3.